Hello, welcome to Lesson 1, Introduction to Electromagnetic Simulations. So in this lesson we're going to look at the uses of electromagnetic simulations and some common software packages that are used. So electromagnetic simulations are incredibly useful. They predict how the EM radiation is going to interact with the structure. So they actually solve Maxwell's equations directly. There's lots of uses for simulations. You can use them to design new products. You can improve the design of existing products. You can investigate how manufacturing tolerance is going to impact on your design. And you can actually use them for fault finding, both from a measurement point of view. When you've taken your RF measurements, you can check that in simulation. You should get a very similar answer. Or for manufacturing. So I've actually used EM simulations a lot for manufacturing defects and done a whole program of study just based around simulation of the faults that we found there. So, as I said, electromagnetic simulations solve Maxwell's equations directly. You can use either the finite element method or the method of moments. Makes very little difference which one you're doing. They both work very well. The main difference is you can take time domain or frequency domain measurements. So time domain measurements use the differential or the integral form of Maxwell's equations and are valid over a wide range of frequencies. The frequency domain actually uses the phasor forms of Maxwell's equations and you solve at a single frequency. You can obviously solve again at another frequency, but you do have to remesh, so it can take a bit longer if you're looking at a wide range of different frequencies. The choice actually comes down to the simulation that you're undertaking, and it is a judgment call for the RF engineer. You'll find also that different areas tend to gravitate towards different ideas as to what is the best solution for them. You can also get full 3D, so you model the world as it is. You can get two-dimensional simulations, so that's a flat one, which is quite useful for circuit boards, for example. My favourite obviously is 2.5D, which is a two-dimensional simulator which has some ability to project into a third dimension. So the common packages and the names that you're going to hear bandied around, you've got CST, you've got HFSS, you've got FICO, and you've got ADS. These packages are evolving all the time. There's a rapid growth in this domain at the minute, and it really is like year on year they're improving amazingly well. You'll find CST is very prevalent in universities because they give their licenses away for free to universities. You'll find that HFSS is a little more prevalent in industry. You find a lot of CST, but you'll find a lot of HFSS. And certainly if you're in an antenna department, HFSS is kind of your tool of choice. FICO is kind of a slightly newer one that's come along, but has made some incredible progress. It's a little bit more all-encompassing. So CST originally was native in the time domain. They've developed to the frequency domain. HFS was originally native in the frequency domain, and they've developed a time domain. FICO actually is kind of native in both because it's pulled together a lot of different packages. ADS, if you're looking at circuit simulators, you'll be using ADS. You wouldn't use a 3D simulator, a native 3D simulator. ADS now does 3D, but it did used to be 2D. And there's all sorts of tools breaking onto the market, so it's something that you need to keep an eye on. So challenges, the scale of the hardware involved. So in a simulation, single simulation, you can go from simulating our tiny little coax cable situated on a plane. So you've got tiny scales in microns to scales in meters. You tend to talk about wavelength, size and wavelength. So if you are working at a very high frequency and you have a small wavelength, then you're going to end up with electrically large models with many wavelengths across. You have to set up the simulations with care. You have to interpret the results with care. A simulation will give you a result, and it can be totally wrong because you set it up incorrectly. So you do have to be careful. It takes a lot of knowledge and a lot of experience to do that correctly. You can sometimes simplify your geometry, which helps. It works sometimes, it doesn't work others. And the other issue you're always going to come across is limitation on computer hardware. You need a large computing capability, preferably a whole suite of computers at your disposal to do a large simulation. So conclusions from this chapter. Electromagnetic simulation can be used for a range of different reasons. The top packages you're going to find in the industry are HFSS, CST and ADS for circuits. You've got to take a lot of care when you do these simulations to make sure that they're accurate and well interpreted.